So here's a question from the acid basis 2. So it says the following question pertains to 0.5 molar of HOCl at 25 degrees and the pKa of 7.46 at 25 degrees Celsius. So for part A, we have to find the concentration of all the species present in solution at equilibrium. Then we have to find the pH of the solution and then identify the strongest base in the system. So the first thing I'm going to do is I see this pKa here. I'm going to change it to Ka so it's a lot easier to work with. So I know that 10 to the negative pKa, okay, should equal my Ka. So that means 10 to the negative 7.46 should equal my Ka, right? And that my Ka, I put in the calculator, should be 3.5 times 10 to the negative 8. So I'm going to have that. I'm going to hold that off for a little bit because I'm going to use it later in my chart. So now what I'm going to do is I'm going to write the equation for this. So I know that this is going to be HOCl. It's going to react with water, which is liquid in this state, and it's going to make basically H3O, the hydronium ion, plus the OCl minus ion. Okay? So now, because I know this is a weak acid, I'm going to use the ice chart. So I know initially the amount of HOCl is going to be 0.5 molar. I don't worry about the water, and I know the amount of H3O plus is going to be 0, and OCl minus is going to be 0. Then what I'm going to do is I'm going to do the change. So I know that as the reaction takes place, I'm going to subtract X here. I don't need water. And I'm going to plus X because that's how much I'm going to make, and the plus X there. So then at equilibrium, I should have 0.50 minus X, don't need this, plus X and X. Okay, so that's my ice chart. So from that, I know then how to write my equilibrium constant expression. So my equilibrium constant expression will be Ka, okay, the equilibrium constant expression, the concentration of the H3O plus, concentration of the OCl minus, over the concentration of the HOCl. All right? So now I have those things though. All right? So it's equal to the concentration of H3O plus is X, the concentration of the OCl minus is X, and the concentration of HOCl is going to be 0.50 minus X. And that's equal to the Ka. And I found the Ka before up top to be 3.5 times 10 to the negative 8. Now, if I solve this now, I have to use a quadratic equation because this is going to give me x squared, right? Now, so I'm going to use the 5% rule. The 5% rule says if this product, okay, the Ka is less than 1 to the 10 to the negative 4, then I can pretty much say it's going to produce less than 5%, so I'm not going to produce so much of this. So that means I can literally get rid of the x there. So all I have then is that equation. So then what it all means is I'm going to take 0.50, okay, I'm going to multiply that by 3.5 times 10 to the negative 8. Then I'm going to take the square root of that because I have x squared, and that should give me the value for x. So after doing all that work in the calculator, I should get 1.3 times 10 to the negative 4. So that's the values for x. So if that's the value for x, then this x is 1.3 times 10 to the negative 4, and this x is 1.3 times 10 to the negative 4, and this x is 1.3 times 10 to the negative 4. So the amount of H3O plus is 1.3 times 10 to the negative 4. The amount of OCl minus is 1.3 times 10 to the negative 4. And the amount of HOCl is going to be 0.5 because when I subtract this, I'm going to get a pretty small number. Then if I have to round it to the number sig fig, I'm back to this number again. Right? So then the second part of the question asks me, what's the pH of this? All right, so what's the pH of this? So remember, the pH is the negative log of the concentration of the H plus ion or the hydronium. So I know that it's going to be pH is equal to negative log of the hydronium or hydrogen plus ion. So if I put in the concentration of that H plus or the hydronium, which is the same as 1.3 times 10 to the fourth, so I get negative log of 1.3 times 10 to the negative 4, and I should get a pH of about 3.89, right? So now the last part of the question asked is, well, which one is going to be the strongest base? So I'm going to go back to my equation, and I know that this is my acid, this is my base, and then this becomes my conjugate acid, and this is my conjugate base. So I know this, the H2O, and the OCl minus is my base. So the question is, which one is going to be stronger? That means if I have another H plus come in here somewhere, is it going to attract to the H2O to make H3O, or is it going to attract to the OLC minus to make HOCl? To do this, I'm going to do is I'm going to look at the Ka. So the Ka is 3.5 times 10 negative 8, which means it's pretty small. And because it's small, it's going to favor the reactants. Okay, so this side is favored. So I want to make this side. Well, to make this side, then this H must be attached to this OCl minus to make this HOCl. And because of that, this tells me that this side right here, this OCl base, is going to be the stronger of the two base. Okay, so again, we have to look at what side is favored, and that H will go to the opposite side to create that stronger base or acid if you want to release it.